Today we're going to take this example, which is significant electrical example, and we are going to our objective is to obtain the block diagram from the bond graph of this example. I think it's important to understand that once we have the bond graph model, we don't need the block diagram. However, we are doing this to illustrate the equivalency of those methods, and if you really want to obtain a block diagram from a bond graph model, how to do it. That's the objective. So we have an electrical circuit that has 3 loops in there, and it has several capacitors, inductors, and resistors. And so let's take a look, and first of all, how we generate the bond graph model, and then what do we need to do to obtain the block diagram. So let's disappear from here, and we have the very first thing we're going to do is we need to identify the distinct currents. So you have in here, this is I1, this is going to be I sub 2, and this is going to be I sub 3. Yeah? So if this is the case, we're gonna put the step number 1, identify the distinct currents and use a 1 junction to represent them. Okay. Okay, very good. So let's just put our 1 junctions over here. So this is going to be, let's say, a 1 that represents I1, a 1 that represents I sub 2, and a 1 that represents I sub 3. So we have done step number 1. Step number 2 is, I will say, attach the elements that experience those currents. Very good. So we will use here, let's just change colors here, and I'm going to use this. On this side, we are going to attach the we have the voltage source, so we're going to put it source of effort with value voltage in there. That's this voltage right there. Then we have obviously you have an I element with value L sub 1, and this is an R element with value, it's funny we put it L1, but okay, it doesn't matter what name we put it. This one right here, we are going to put an I element with value L sub 2, and then you have this other one, this R element with value RL2, like this. And then in here you have another I element with value L sub 3, and then this other R element with value RL3. But also this is connected to a C element with value C sub 3, and is connected to a resistive element with value RC3. The notation really doesn't matter. So we have fulfilled step number 2. And now we need to go to step number 3. Step number 3, use a zero junction to represent the current differences. Okay, all right, very good. And so you see what happened in this, what happens in this case is, over here you have the current like this, and over here you have this other one. The elements that are in between this, see the difference between this and this other one. And the elements that are in here, see the difference between this and this other one. So what you have in here is we create a zero junction here that has the difference between I1 and an I sub 2 would be like this: I1 minus I sub 2, and this other one you create this other difference also, which is I sub 2 minus I sub 3. Very good. So if this is the case, you have we have done this step number 3. And now what we are going to do is say attach the elements that experience those current differences. Very good. So if this is the case, you can see that in here, this and this see the different currents, and this see also the difference between those two. So we need to attach those elements. In here we will have the element C with value C sub 1, and on this other one we will have the R element with value, we're gonna RC sub 1. And this one you can put any name that you want, so that as long as it makes sense to you and is for easy reference. So this is C sub 2, and also this other element, this R element with value RC sub 2 is what we have. I think it's important to notice that we have finished the basic structure of this bond graph model of the entire system. This would be enough to put this into the CampG software, because the CampG actually numbers the bonds and also assigns the causal marks. So if we really wanted, we could just directly put this bond graph model for simulation into the CampG software. So, but in this particular case, we are not doing that. Our interest is in generating the block diagram. So in order to do this, we need to perhaps add one more step and say, I would say, complete the causal marks and revise, or we say verify power flow, so that everything is correct. I think also for reference we could say one last thing. You could say number the bonds. But that is not necessary for ChemG. It will do it by itself. The reason that it becomes an issue here and it's important is because we need to refer to each signal by its name, and therefore we need the numbers. So this is number 1, number 2, 3, and 4, and 5, and 6, and 7, and 8, and 9, and 10, 11, 12, 13, 14, 15 here, 16, 17, 18, and 19 bonds. Very good. And then let's do the causal assignment. And I'm going to switch to my red pen so that you can see. ChemG would do this, would put the numbers, and also it put the causal marks. But since we're doing it by hand, I think it's a good idea to do this. And I would like to perhaps outline here, you may say, steps to assign the causal mark. Okay, so I'm just going to go and say, okay, the first step is going to be assigned the marks to the sources, because we know this is something that we already know. Like, for example, the source of effort has to have the causal mark this way because it's a source of effort, right? There's no other one in here, no other source. So we need to go to the next step, and the next step is you assign the marks to the I elements in integral form. Okay, and I would say propagate the assignments as much as possible, following, you could say, following the junctions. Okay, so what do I mean by this? You go and put the causal mark on this, you put the causal mark on this right here. Yeah, you see that assigns integral form and sets the flow to this one. And when I say propagate as much as possible, it means these others have to be like this, because this flow too, the controls and assigns the flow for all the junction and makes the other ones like this, because the one junction can have only one flow in. If we do it to the next, look what happens. If you put an integral form in there, this too, this will have to be like this. If we assign it to this one, all these others will have to be like this. See? Like this. And if you calculate this, you propagate as much as possible, I think that it is important to put another step. You could say assign the marks to the C elements in integral form. But you see, we need to make sure that if we propagate the causal marks, we can actually, although we want the Ising integral form, we still can observe that in here you have two flow inputs, and you'll assign this causal mark this way, because the zero needs an effort in. So if you do that, we are still on step number 2, propagate it as much as possible. These two are like that. This requires to be like this because it needs one effort in. But you see, the moment you do that, this sets the flow over here and puts, in fact, the Ising integral form. But if we had not this situation that completes, then you would start by assigning the Ising integral form. So in here, this completes like this, and we are completely done. So this bond graph model that you see in there has everything in there. And then you could say assign the Ising integral form. Then you could say expand the assignment as much as possible. You can say until you finish, basically. So these are the steps. So now I think we need to put another set of steps that actually will generate the block diagram. So I'm going to put the steps to generate the block diagram. And we're going to go to step number 1. I would say step number 1 would be, because it's a block diagram, I'm going to say draw two lines for each bond representing the effort and the flow on each bond. So that would set also the whole structure for the system, right? So in here we will have to make some space a little, farther in here, so that we are able to cover all this. So in here you could start anywhere, but I would suggest that we start from left to right, and just put the bonds the way they are in here. Like you have this, let's see, now let's start over here so we have enough space like this. See, so this corresponds to those two. Then you have the I element. The I element needs those two. The R element that you see in there needs two also. And then you have this in here, you have a connection in here. These two represent this one, and we need two for the other side, like this. And then we have one that is going down like this, and then we have this too. See, so we need to put those in here, and generously with space so that we are able to put the signals and the names and everything. So far we are right here, this one. We need to do the ones for the I element and for the R. So I would put them like that, and the other one like this. For the R element, you have also this one here, which is a connection in here. Yeah. And then you have that one. I just drew this one. And then we need this, and then the structure on the bottom. So this would be number 15, like this, and then we are going to put those two. Is this one like this, and then we have to generate for the C and the R. Do you see how the structure takes shape of the bond graph model, of the block diagram? And so far this bond represents this joint right here. So we need to put all this. So we are following this step, generates 2 lines for each bond. We are not done yet with that. So what we want to do is, okay, we still need to generate for the I element up there, now for the R element right here. And then see, we okay, where are we? We are here, right? We did this, and then now we need the 2. This is the I16, right? And then the R element, which is over here, and then we have a C element, which is over here like this, and then we have this R element, which is like this. But also on this side, I think we are done basically, aren't we? Because I just did it for the R element, which corresponds to that. Okay, so what's our next step? Right now we have outlined the structure for the entire model, and we need to begin building it from left to right. And so first let's move this up a little bit so that we can do all these things over here. So what should be the next logical step that we have in here? The next step is going to be, so we draw 2 lines for each bond. Then we need to draw, you could say, draw the constitutive laws of each element following the causal marks, because that's what determines the constitutive laws, or you could say constitutive. I think I'm gonna put in parentheses equations. Okay, that's why it's important to know the constitutive equations. So in here I am going to assign the, this is the structure, but because we are changing to do a different action, I'm going to use another color. So in here you see this is the element of the source of effort, which is the voltage V, like this. And obviously what this does is going to put the effort E1 over here and F1 this way, see? And then you have the in here we have the I sub 2. I think it would be a good idea to just write the numbers on each one of these, so we don't have to worry about this, and see F sub 2 is coming out like this, and then this is E sub 2 this way, like that. Do you see E sub 3 is like this, and F sub 3 is like that. So let's do it for all the bonds so that you can see this is E sub 4 this way. I'm following the causal marks, and this is F sub 4. I'm just basically reading what I see. This one right here is E sub 8, and then this is F sub 8, and this one is E sub 9, this is F sub 9, and the one over here is yeah, but I mean, let's just put the direction reading. This E sub 9 is what goes this way and comes F like this, and this other one on E10, you can see E10 is this way and F10 is this way. And then over here this is E16, 16 like this, and out comes F16, the one over here, so this is E15 like this and F15 like that. And then on the right hand side, wait a second, I think I just messed up, because that's not 15, that is number 11. So let's just correct that real quick with erasing these ones right here. So let me see if the directions are correct, to make sure that, and the directions are not correct, because E11 is the other way. It's like this, and this one also is like that. So this is E11. Let's just do it right. I don't like this overridings in there. We'll just do it right. And in here we have this. Okay, so where were we? This was E11. E11 is this way and F11 is the other way. On the right hand side you see this is E15 and F15. So this way we do it in a systematic, organized way. All these assignments, and we recognize what's on the graphing here, and in here you have the number 10. This is you know what, I think I have a little, oh, this is 16. Okay, I thought it was 10. So on this one, on the 17, we see E17 this way and F17 like that. We see E18 like this and F18 this other way. And then of course on the number 19 you see that E19 is like this. I try to put efforts on the left, flows on the right, so that we have organized. And you see, and this is E sub 12, which is E12 is like this and F12 is this way. And then you have E13 in here, where the effort is this way and flow is F13, and the one over there on the 14, you see that the effort is effort E14 on the left, then flow F14 on the right hand side this way. Yeah, and I think we are done, except that on the left we didn't finish this one, that is number 5, 6 and 7. So E sub 5 and F sub 5, and you see that E5 goes this way and F5 goes this other way. Finally E sub 6 in here, that goes this way, and F sub 6 goes this way. And then you have E sub 7, which goes like this, and F sub 7 goes this way. Very good. So now that we have put the numbers and the directions of the flows on each one, perhaps let's draw the constitutive equations on each element following the causal marks. And so let's do that. I think perhaps maybe we should make a comment about this. We say keep in mind the direction of efforts and flows. Very good. So keeping that in mind, we are going to do the we're going to come and do the constitutive law of the I element. You see the effort is going in. This thing gets let me see, gets integrated by 1 over S, and then you have the multiplied by 1 over I sub 2, and out of this comes this way. This one here, this R element, E sub 3, F sub 3 goes in, gets multiplied by R sub 3, and out comes this. And we continue with every single one like that. Since we have visibility on the top, we'll continue with those, and we'll take number 9, which it has the effort in. How does this work? You take this is 1 over S and gets multiplied by 1 over I9, and out comes F. On the right hand side over here, you have that the flow gets multiplied by R, in this case R10, and out comes the signal like that. Let's keep doing it here for the I element. You have that the effort goes in, and in here gets multiplied by 1 over s, right? And then by the gain here, 1 over I16, and now comes the connection. These ones here on the bottom, they are just connections. We are not done with this step for all the other elements, and that's what we need to do right now, is to finish it for the, see, you have this I over here and the C. So this is the I, which is 16, no, 17, excuse me, and this is the, you have the R element gets multiplied by this R17, and out comes this one. The C element, you have the flow gets integrated by 1 over s. This thing gets multiplied by 1 over c sub 18, and there is E. Let's do the R element over here. You have the flow gets multiplied by R19, and out comes the effort like that. So I am building based on all the constitutive relationships of each single element. This would be R14, and there you have. For the C element over here, for this one, you have that in here gets sorry, I was starting drawing wrongly. This is 1 over s, and then it's gotta be multiplied by the gain in here. We need to erase this. That is not quite right. Okay, so this gets multiplied by, this is C13, and comes out like that, right? And then we have just 2 more to go, and then we have to do the junctions. So this is the procedure. So in here you have the one for the C sub 6. You can see that this comes in here, gets integrated by 1 over C 6, obviously, no, 1 over S, and then gets multiplied by 1 over C 6, and then comes out like that. And then of course on this one you have the flow gets multiplied by, this is R7, and then comes out, and we have finished all the individual constitutive relations. So the next step in our generation of the block diagram is going to be step number 3. I would say draw the connections on 1 junctions, and here a common flows, and then summation of efforts. You could say according to the equations at each 1 junction. So let's just do the 1 junctions now, and the first one that we're gonna take on is this one right here. All the flows are the same, so I'm just going to change colors to illustrate the connections that I'm doing. All the flows are the same, right? So we could put this right here as a connection. The flows are the same in here. You see all the bonds converge to the same point. So all of them are the same. But the efforts will have to add. So you see, pretty soon you're gonna realize there is a little hole in here that it needs to be filled. I don't like that intersection, so I am going to perhaps draw it a little nicer over here. And so I am gonna draw it so we don't interfere with the lines. So right here, okay. So this will converge to add to here. But how? What are the signs or so? You see what happens? All of them converge except E2. E2 is the output. But we need to remember the equation of this in here. So let's erase this line in here, and what's the equation in here of this one junction? It says that E sub 1 is equal to E sub 2 plus E sub 3 plus E sub 4, right? But you see the equation here is written in terms of E sub 3. So in reality, is E sub 3 is equal to E1 minus E sub 2 minus E sub 4. So if that's the case, see, this is, what am I saying? E sub 3 is E2, excuse me. E2 is equal to E1 minus E3 and minus E4. So then you will have E1 is plus minus E sub 3, which is this way, and then minus this one. So we are done now with this junction. Let's do the other one because we're trying to do it in order. Common flow, you put it over here. You see, common flow. All this are here like this, and so is this. But you see right here, you can see the hole, so that the efforts will add this one and you will add this one. But how? You see, this is coming this way, all this. The one going out is E sub 9. Is that right? Yeah, it's E sub 9. Yeah, E sub, am I correct? Yeah, this is E9, 9 in here. So the question is, seeing here the equation, how is it? The equation in this bond, it says E8 is equal to E sub 9 plus E sub 10 plus E11. But you see, this equation, the way it's written here is in terms of E sub 9. So really, this is E sub 9 is equal to E sub 8 minus E10. E sub 8 minus E sub 10, and then minus, what's the other one? E11. So E11, this is a minus, 10 is a minus, and this is a plus. And then we go to the right hand side to do our, again, the same thing, common flow junction right here. Right there. All the flows are the same. See? They are all converged to the same point, but the efforts will add, and they will add according to the equation. See, we'll put the efforts in here. On this one over here is saying that E15 is equal to E16 plus E17 plus E18 plus E19. But in here the output is E sub 10. E16, excuse me. So what this is saying is that E16 is equal to what? E15 minus E17 minus E18 minus E19. And so this would be all minus plus. Yeah? And we are done with that junction. And we have only 2 more to go, no 3. On this, we are still doing the 1 junctions, right? So let's do it the one over here. The flows are the same. Okay, but the efforts will add. So I'm gonna do it a little quicker. Here's E5 is the output, right? E5 is the output for the effort. So it's E sub 6 plus E sub 7. E5 is E sub 6 plus E sub 7, so plus over here. On this one on this side, all the flows the same. So we're gonna go over here. All the flows the same, but the efforts will add. So we have this one. But see, the way that reads here, just so that you see this, the equation says that E sub 12 is equal to E13 plus E14. In our block diagram down here is E12 is the output, so this coincides, they are plus. And then we are almost done. We need to do the last one that says draw the connections on 0 junctions. This would be common effort junctions. Again, you say summation of flows according to the equations. To the 0 junction equations like this. Very good. So in this case we do the opposite. The efforts are the same, so we put all this in here, you see, and then we have to add the flows, and the flows are added based on the equations also. Right here it says that F4 is equal to F8 plus F5. So 4 is equal to F sub 8 plus F sub 5. How is it written this in here? It says that F5, which is equal to F sub 4 minus F sub 8. So that means this would be plus and this would be a minus. Yeah? On this other one we do the same thing. The efforts are the same, but the flows will add. So in here you have how do we have it in here? That F12. So in here you have that F11 minus F15 is equal to F sub 12. And if that's the case, you have F11 and then minus F15 equals to F12. And we are done with this thing. You can see the steps in here, you can see the bond graph here, and you can see the block diagram over here.